decimals go on forever, but today we are going to stop at the 10,000th place. 10,000th place. So let's start here with the 6. This is the whole number 6. The first digit after that is the what place? Tenths. I'm going to put that TH on there. And then you have the hundredths. Again, TH. And then you have the, what would be the next one? Does anybody know? Tens, hundredths, Leighton? Not yet. Thousandths. And then today we're stopping with this one here, which is the 10 hyphen thousandths. TH. Okay, and you have to remember, as you get farther away from the decimal, those digits, those place values mean significantly less. Just like with money. In money, we have this. This is a dime. 7 dimes, 70 cents. This is 8 in the hundreds, which is a penny. That's like having 8 pennies. If you go to this one right here, that's like taking a penny and cutting it into 10 equal pieces, and you're having 4 of those. Okay, you would need 10 of these just to make 1 cent. Okay, so this is a really, really small digit here. And this one here is even smaller still. You would have to have 100 of these to get to a penny. You know, if we had money and I gave you this much money, okay, if you had 100 times that, you'd have 4 cents. Okay, that's how small that is there. And that's why sometimes if you go into the store, and people have this written down, you can kind of laugh at them. They have a price tag like this. You can't mix cents and decimals because they're two different things. You either have to list something as 50 cents with a dollar sign, or you just say it's 50 cents. Those are your two acceptable things. What you're actually saying here is this thing costs 5/10 of 1 penny. Okay, so you could buy 10 of them for a nickel. Each one really is costing 1/2 cent, because that's what this decimal means. So you really could buy a lot. If they gave you this, that thing cost 5/100 of 1 cent. So you could buy 100 of them for a nickel. So you have to watch, you know, if you're not careful, people will make fun of you at that, but that's neither. We don't have money that goes into those thousands and 10,000s places just because they're so small. And we don't usually, you know, we don't usually use those. There's not very many places they work. They come up in science and stuff, you know. If you look at what fraction these stand for, maybe this would put it into perspective for you. Let me erase this here. If I were making fractions out of these decimals, this is what? 7 what? Tenths, right? So as a fraction, it is 7/10. This is 8 what? Hundredths. So as a fraction, it's 8 over 100, 800ths. This is 4 thousandths, which means as a fraction, it's 4 over 1,000. You're getting kind of small. And then this one is 3 10,000ths, and that's very tiny. 3 10,000ths. Those are very small fractions, of which you probably don't want to deal with that. But you need to be able to. We've talked about writing these out, right? I mean, how do you actually say this number here? If I asked you to write that in words, we already done this, haven't we? How do you say 6 point and don't say 6.7843? I just read it that way so you don't get confused. How, Caleb, do you do that?
6 and 7,843.
I think you might have been right there. It's 6, you say the number on the left side, 6, and for the decimal, then you have to think about how you would say that number if this, pretend that decimal part wasn't there. It's 6 and, this is 7,843, and then whatever last place this is, 10,000ths. 6 and 7,843 10,000ths would be how you would say that. Is that what you said? Was it something like that? Let me see another one. How about this one? 13.063. How would you say that decimal? How would you say that decimal? Joseph?
13 and 63 thousandths.
Yep, tens, hundreds, thousands. 13 and 63, that's in the thousands place. Tens, hundreds, thousands. How about this one? 101, period, 1010. Grace?
100 and 1,010.
Yep, that's exactly it. 101 and 1,010, whatever place that is in 10,000ths. I think it's kind of got that there. Let's look and see what. How about this one? Round to the nearest whole number. Was that what we talked about before? Round 13.4387 to the nearest whole number. What would that be? First of all, what are whole numbers? Whole numbers are numbers that don't have fractions or decimals. So you're taking 13.4387. Your two choices are going to be, either it's going to be 13 or 14. Those are the two whole numbers that this falls between. What would it be, Lauren? 13. Why? Exactly. And this is the only number that matters. Did we have I talked with you about this in 6th grade? This number after the decimal is the only one that matters. You can write decimals forever. Since this is 4 or less, it stays 13. If this would be 5 or greater, which means it's more than half, like Lauren was saying, it would be 14. You know, I can have this 7,342 point 3875943962481. And what's that going to round to? John?
7,342.
Right, because nothing else matters except this one here. This is like having $7,342.38. This is 7/10 of the next cent. So if you were rounding this to the nearest penny, you'd actually make that a 9 because this one is more than half of a cent, 5 would be half. But if you're rounding to the nearest whole number, it's just that little gem right there. Is there something else that's little? Or how about this? If you're comparing this, 4.5 compared to 4.56. 4.56. Oh, I'm sorry, I got that wrong. There was something different. 4.456. Which decimal is bigger? Which number is bigger / smaller? Chase? Yeah, 4.5 is. Why? Because 5/10 is always bigger than 4/10, no matter what comes after it. If it helps you, you can add zeros at the end of this, and this would make this 500, and that would be 456, and you would end up with the greater than sign there. That's exciting.
Yes, it is.
Okay.